Down to the road, right into the distribution, going to the end users. So rather than one big power plant providing power for the entire city of Long Beach, we can build 1,000 small plant solar around the city of Long Beach and provide that power. And we don't have to worry about all these big lines overhead, underground, substation, switching station, this station, and all those crazy guys that they're controlling our lives every minute and switching this line. Oh, these guys are not important. We can shut them off. Well, this factory is very important. Let's give the power to them. And they do that all the time. They have a priority. They have a list of priorities. Like, for instance, hospitals are a #1 priority. Under no circumstances you can shut down a hospital. That's why hospitals, they bring power from 2 separate substations. So if one of them fails, the other one that comes from another substation is still providing power. So that's what they do. But your house, my house, who cares? They flip the switch. They say, oh, let's have these guys not have the power for a couple hours. If you're a big manufacturer and you're buying the power and you're a big customer, guess what? Edison will never, ever shut it down. But you and I, piece of cake. Campus, not a problem. Kids going to go home and relax and they have fun because there was no school. So, I got to learn how to work with this app. Now, the power distribution system, they have substations that these substations mainly owned by the utility companies. Large customers, they have their own substation. For instance, this campus, we cannot bring so many lines from so many places to this campus. That will create a chaos. You can't control it. So what we do, we bring the power to one location in the campus called customer substation. So all the power comes there in that campus, which is located next to your central plant down here. From there, we're going to distribute it to all the buildings within the campus. So we have an internal distribution system inside the campus and external distribution that belongs to the utility company. Now, the primary distribution happens in a very high voltage. And that comes to the counties, cities, and territories that utility companies cover. Secondary distribution is a mid voltage. That's why from the substation goes to the various streets and alleys and rural avenues. So that's the second one. And tertiary distribution, when it actually comes to a residential home, businesses, and somewhere like this campus. So every time we have a high voltage come to the substation, we bring it down to the primary source from substation coming to the city of Long Beach, for instance. Then we bring it secondary from the city of Long Beach. We distribute it to various streets and various areas of Long Beach. Then we go to the low voltage. That's going to be distributed to actual customers. All the customers, actual customers, connected right here. Now, we talk about the renewable energy sources, how important they are. They are the future for this country, for all other countries right now. Spain uses generating 70% of their power through renewable sources. 70% of their power that they use, it's all renewable. Only 30% is through nuclear and fossil fuel. Yes.
Do you know what Spain's main renewable form of energy is?
Wind. Wind and solar are the two major components. Spain are the leader in the solar energy, so is Germany. And basically all European, with the exception of Italy and Portugal, all European countries, they're way ahead of us. Yes?
What did you say was the other one for Spain other than solar?
Wind and solar,
Wind.
those are the two. Number one is wind. So we have a wind power. If you go to Palm Springs, you're driving on Highway 10, on the left and right you see a bunch of wind turbines. They're old. They generate a very small amount of power. They're all 100 kilowatt. Now the technology today, we have a wind turbine that can generate 1.5 to 2.5 megawatt for each one. The technology has changed. Now we design the propeller of the wind turbine that runs with the smallest amount of wind. If we have a wind of 3 feet per second, we can generate power from that. That's a new technology. And it doesn't matter which direction that wind comes from, because we design the pitch of the propeller that will pick up the wind in any direction and run the turbine. The old one, the one that you see in a Palm Springs, when you go in a Palm Springs, they design only if the wind comes in this direction. That's why you see some of the wind turbines with different angles. That's 20, 30 years ago technology. Today technology has changed. So now we can do a lot of wind power. There are a lot of areas in the United States that you have a constant wind over 15 feet per second, 24/7. It's like a wind tunnel. We can, do that. Holland, again, number one on wind. They generate a lot of power on wind. They even put the best place to put this wind turbine is right by the ocean. Right here, we love the ocean. That's ugly. We always look at the ugliness of things, but we don't look at the practical part. So they put it right in the ocean and generating tons of power because they constantly have wind in the ocean, and that's why they generate too much power. So we have solar power. There are two ways of doing the solar power. One is called PV system or photovoltaic, which is basically a silicon and photon, which is a ray coming from the sun, will hit the silicon and instantly generate DC power. And then we collect all of those through the solar panel. We convert it to AC and we use it. The other one is called thermal solar. Thermal solar is when the solar panels are not the panels of collectors. We collect the sun, and the way we collect it, we focus it on one area. It's called concentrated solar panel. And then behind that panel, we put a fluid, or we can even put the water. And that water, or that fluid, becomes very hot to the steam stage, and then we run and a steam tape.